Okay, so diagram 1 shows the release of electrons, question number 1, from a metal surface when illuminated with light at a certain frequency. Okay, this is a very important statement. Okay, bila dia disinari cahaya pada frekuensi tertentu, okay, with being illuminated, first thing you need to know that this is a definition. Okay, the release of electrons from a metal surface, the release of electrons from a metal surface when it is illuminated by a light of a certain frequency immediately tells us that the first answer over here state the process. This is a definition for the photoelectric effect. Okay, kesan photoelectric lah. So, a lot of people that want to join. Okay, hold on. Okay, so it's photoelectric effect. Now, just to recap once again, we have two situations in our syllabus now, okay, yang melibatkan the release of electrons from a metal surface. Okay, one, okay, is photoelectric effect lah. Ini saya sudah cakap. Okay, the definition of photoelectric effect is this. Okay, release of electrons from a metal surface when illuminated by a light of a certain frequency. The second one, okay, is thermionic emission. Thermionic emission, pancaran termion lah. Okay, which is chapter 5 in form 5. Now, thermionic emission, okay, if you remember from the Terengganu class, the definition now is very, very similar. Okay, it's the release of an electron from a metal surface, cuma dia punya syarat itu saja yang berlainan. Okay, the condition for this to happen is only different. Thermionic emission is when the metal is heated up. Okay, so this pink color one, this pink color highlight that I'm showing you over here, okay, is the only thing that is different, okay, in terms of the definition. But the beginning of both definitions are the same. Okay, for photoelectric effect and for thermionic emission, dia punya permulaan itu adalah sama. Pembebasan elektron daripada permukaan logam. The release of electrons from a metal surface. Okay, I highly suggest, this is one of the easier definitions to remember. So I highly suggest that you start committing these two definitions to memory. Because the starting is the same, cuma dia punya penghujung itu lain. Photoelectric effect is bila kita pancar cahaya. Thermionic emission is bila kita panaskan itu logam. Okay, so very simple definitions. You should aim to answer these kind of definitions because it's not very difficult. Okay, what is the factor that affects the velocity of electrons emitted from the metal? Okay, this one we have to go back to Einstein's photoelectric theory. So Einstein's photoelectric theory tells us that the photon energy equals to the work function plus the kinetic energy. Okay, and so since we're talking about velocity, okay, then of course we're talking about the kinetic energy lah. Okay, so apa yang mempengaruhi, okay, the electrons, the velocity of the electrons. So one, okay, it can be the light energy. Okay, one possible answer is the photon energy or the light energy lah. Okay, either one also can. But we know that the light energy got two formulas. Okay, one of the formula is E sama dengan HF and the other one is E equals to HC over lambda. So in some sense, okay, the frequency of the light and the wavelength of the light also affects, okay, the velocity of the electrons. Okay, so ada pelbagai jawapan lah untuk ini. There's more than one answer. One answer is photon energy, the other answer is light frequency. Okay, frequency cahaya. Another one is wavelength. Okay, wavelength of the light lah. Any one of these is a fine answer. What you should not be answering, of course, is the work function because the work function is a set thing. Okay, it is set and you cannot change the work function sebab itu bergantung kepada the type of metal. Different metals have different work functions, so it's not a factor that affects the velocity lah. Okay, remember Einstein's photoelectric theory cakap, okay, that itu cahaya, the light that is shining on the metal, okay, has energy. Okay, and this is, I'm going to use yellow color lah. Okay, the light has energy and then some of the energy digunakan untuk membebaskan itu electron, which is the work function. Okay, used to release the electrons is the work function. So the remaining energy, the balance energy, okay, is used to move the electrons because when the electrons are released, okay, bila dia terbebas bahkan, dia actually is just out here lah, you know, la 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 begitu. Okay, it needs energy to move. Okay, it needs energy to move, and where does the energy come from? From the balance energy. Okay, itu the baki tenaga daripada cahaya itu, lepas dia dibebaskan, the balance energy is what moves the electron. Okay, so that's why, okay, we have Einstein's photoelectric theory lah in this equation. Okay, it's a very, very easy to understand equation as long as you know that, okay, sumbernya adalah cahaya, and then dia digunakan untuk dua benda. One is to release the electrons, the second one is to move the electrons. Okay, and then after that, you're good to go. Okay, what happens to the maximum kinetic energy if the electron, okay, again, maximum kinetic energy. So I'm bringing you back to this, E equals to W plus KE, okay, kinetic energy. So what happens to the maximum kinetic energy, which is this, okay, if the light intensity decreases? Now, if you take a look at the equation, tiba-tiba ada light intensity tau, keamatan cahaya, yang apa kaitannya? Okay, so we have to remember this. Light intensity means how bright or how dark is the light. Dia bukan bercakap pasal jenis warna apa, kind of light. Nobody is asking about that. Light intensity is whether it is a bright or a dark light. Okay, so the brightness, we don't say brightness now, we say intensity. So the intensity of the light actually doesn't affect this equation at all. Okay, so what you're going to get is an answer unchanged. Okay, and you should make a note here, the light intensity only affects the number of electrons. This is true. Kalau semakin terang, okay, if the more intense the light, the more electrons will be released. Okay, tetapi how much kinetic energy that electrons have doesn't depend on the brightness of the light. Okay, this is very important. And I have seen questions before, dia tanya ini, okay, what happens to the maximum kinetic energy or what happens to the number of electrons? So be very, very careful about this, okay? The light intensity affects the number of electrons, the frequency affects the kinetic energy, okay? Now, if you go back to the formula, okay, the formula says HF, okay, if you have a bigger frequency, you are going to have a bigger energy. Okay, having a bigger energy means you are going to have a bigger kinetic energy because the work function is never going to change. Okay, the work function only changes kalau the metal changes. Okay, different metals have different work functions. The work function is like a syarat lah, you know, it's like a condition lah. Kamu mau elektron, kau kena bayar lah sekian-sekian banyak. You have to pay me some energy, then I will give you some electrons. So the remaining energy you have will be used to move the electrons. So when the frequency of light increases, according to this, the kinetic energy also increases. Okay, and just to remind you once again, if you see a question that says, what happens, there are generally three types of answers. Increase, decrease, unchanged. Okay, bertambah, berkurang, tidak berubah. Either one of these. Okay, so even in an exam, if you don't know what's happening, okay, like if you're so blurred that like, okay, saya tidak tahu ni macam mana mau jawab. But I know that this is a question yang cakap, apakah yang akan berlaku? What's going to happen? Okay, tembak. Okay, it's one of these three answers. Most of the time lah, okay, it's one of these three answers. Okay, just give it a shot and make sure you don't leave the answer empty. Okay, especially if you know that, okay, kalau jawapannya, no, if it's a what happens question, it can be increase, decrease, unchanged. Okay, don't waste the space. All right. Number 2, okay, Titan is a moon that orbits the planet Saturn. Okay, be very careful. Titan is the moon, the Saturn is the big planet. Okay, the mass M and the radius R of Titan, okay, is 1.35 times 10 to the power 23 and 2575 kilometers, okay, respectively. So a rocket of mass 1 times 10 to the power of 5 kilograms, okay, is launched vertically. Okay, kamu ada satu rocket lah yang launch vertically with a velocity equal to the escape velocity of Titan. Okay, so just imagine lah, you have this rocket over here. Oh no. Okay, dia dilepaskan and it has a velocity that is equal to the escape velocity. Okay, formula for escape velocity is 2gm over r. Okay, square root. Okay, most important thing you need to remember about this formula, kebanyakan, hampir semua formula yang melibatkan kegravitian, gravitation formulas, most of the formulas, okay, the mass, okay, is always the mass of the center, the mass of the planet. Okay, only one formula. I discussed this in the Terengganu paper. Only one formula, which is the centripetal force formula, mv squared over r. Okay, this one, astaga, sorry, wait. This mass, okay, over here is the mass of the thing yang sedang mengorbit, not the center. It's the only formula that you use the mass of the smaller one. Every other formula use the center mass, okay, the big mass. Okay, so let's talk about the definition. What is meant by the escape velocity? Escape velocity is the minimum velocity. Okay, minimum velocity needed by an object to overcome the not the lah, okay, a planet's gravitational force, gravitational pull, gravitational force lah. I think force is better. Okay, minimum velocity needed by an object to overcome a planet's gravitational force to escape, okay, to outer space. Okay, keyword for this, okay, is the word minimum. Okay, minimum velocity to overcome gravitational force. Basically like that lah. Okay, these are the keywords that need to be in there for your definition. Okay, for your definition to give you that full mark. Okay, calculate the escape velocity of Titan. Okay, let's identify everything first. Obviously, this is one mass and this is another mass. Okay, so we have to be very clear about this. The formula for almost everything except for centripetal force, ini yang kita tidak mau tengok ni hari. Okay, we're using this mass. Okay, ini tiada kaitan. So the question then becomes, kenapa dia mau bagi ini 1 times 10 to the power of 5? Because one of the things that definitely they will test, okay, kalau keluar soalan yang begini bahkan gravitation, even in paper 1, this happens. They will give you both masses and they will ask you to decide which mass is it that you're going to use. Then some people will be like, don't know lah, whichever lah. Ada yang pergi campur dua-dua lagi. Okay, don't do that. Okay, you have to choose one. Remember, hanya satu sahaja. Okay, there's only one formula that involves the outside punya mass. Okay, every other formula involves the center mass, yang di tengah-tengah, okay, yang di pusat orbit, the center of the orbit. That's the one. Okay, so this is the mass we're talking about. Okay, then you have 2575. This is obviously the R, but I want you to notice the red flag over here. This is the big red flag. Okay, it's in kilometers. Okay, yeah, I know. Exam questions tend to do these kind of things to trap you, to see whether you notice the unit or not. Okay, ideally, because what is our unit for velocity? Unit for velocity is always meter per second. Okay. Yes, you can change it to kilometer per second. I'm pretty sure somebody is going to ask me this. Yes, you can put it at kilometer per second. I don't think it's a very big issue, but I think you should always aim to answer according to the according to the SI unit lah. Okay, I think it's always safer to do it that way. Okay, so the first thing you got to do is change the 2575 kilometers, okay, to meters. Okay, so it's just 10 to the power of 3 lah. Okay, and then you substitute it in. So V equals to 2 GM over R square root, which will give you 2 times 6.67 times 10 negative 11, I think. Okay, times the mass is 1.35, okay, times 10 to the power of 23. Okay, over the R is 2575. Oh yeah, kita sudah buat ni, R. Okay, 2575 times 10 to the power of 3, the whole thing square root. Okay, so you will get, if you calculate everything correctly, 2644.58 meters per second. This is of course 1 mark, this is 1 mark. The final answer with the correct unit is 1 mark. Okay, just to remind you once again, sometimes you will see a calculation which has 3 marks. Okay, and sometimes, not always, sometimes there is a mark, okay, if you just write the correct formula. Okay, sometimes, not always. Okay, so if you notice the way I write my answer, okay, I always begin with the formula that I want to use. Okay, make it a habit. Write down the formula, even if your maths, if your admaths is like 99%, okay, if your admaths, you're always getting 100% for admaths, there's totally no problem admaths, okay, just write the formula down anyway. Okay, you lose nothing, okay, except for 3 seconds, okay, by writing down the formula. You just never know if that formula itself will give you a mark. Okay, so make it a habit. All right, state the change in escape velocity if the mass of the rocket is twice its original mass. Okay, this is, yes, a trick question. Once again, saya bagi tahu what is the change. Apakah yang akan berlaku? Standard answer is 3 answers: increase, decrease, and change. Okay, tapi dalam soalan ini, V equals to, okay, 2gm over r. Okay, what is the mass involved here? This is the mass of the planet. Okay, so nobody cares about the mass of the rocket. The mass of the rocket doesn't affect the escape velocity. Okay, let's not go into technicalities now. Okay, just for Form 5 level, yes, it does not affect. Okay, so the answer will be unchanged. Okay, because the mass of the rocket does not affect the escape velocity. Okay, ini we see centripetal force. Okay, this mass, kalau centripetal force, ini adalah the mass of the rocket. Okay, or the satellite lah, yang mengelilingi. Okay, the one that's going around. So sometimes the question will ask, what happened to the centripetal force if the mass of the planet menjadi lebih besar? Okay, or yeah, if the mass of the planet menjadi lebih besar. Reality is, the mass of the planet doesn't affect the centripetal force. It's the mass of the rocket. Okay, so be very, very, very careful about this. Okay, 2 ways this question can be asked. But anyway, the answer for this is unchanged. All right, let's move on now. Question number 3, diagram 3.1 shows the basic structure of a nuclear reactor. The nuclear reaction that takes place in a nuclear reactor is nuclear fission. Okay, pembelahan nucleus. Okay, so of course, this is one of the more famous definitions. Okay, fission is more famous actually. So fission is pembelahan. Okay, pembelahan maksudnya dari satu yang besar pergi 2 atau 3 yang lebih kecil lah. Okay, tapi dalam definisi kita di Form 5, we are always interested in 2 smaller nuclei. Okay, so nuclear fission, okay, is a nuclear reaction. Okay, this first one maybe not so necessary lah. Okay, a nuclear reaction where a heavy nucleus, okay, nucleus yang lebih berat, okay, splits into, okay, 2 or more, okay, lighter nuclei. Okay, don't worry about the plural and the singular for nucleus and nuclei. Okay, don't worry about this. Okay, and releases, usually it's 3 lah. Okay, I'm just going to put neutrons, okay, and energy. Okay, either I'm writing too fast or my handwriting is too ugly. Okay, heavy nucleus splits into 2 or 3, smaller or lighter nuclei lah. Okay, and releases neutrons and energy. Okay, a lot of energy lah. Okay, so that's the basic definition for nuclear fission. Okay, how are the moderators? Okay, so in a nuclear reactor, 2 main components. One is the moderator. Okay, we're going to talk about moderator first. The moderator's function, okay, is to control the rate of nuclear fission. Okay, mengawal kadar pembelahan nucleus. Okay, so it is used to slow down. How does it control? It slows down. Okay, slows down the fast-moving neutrons. Okay, this is jawapan yang sangat standard. Even in section B and section C, if you see this moderator, okay, let's say, but actually nuclear came out last year already. moderator's job, okay, is basically to slow down the fast-moving neutrons. It is an answer that you should memorize as a set. Okay. Another thing that you should also memorize is there are basically two very famous moderators, okay, which is graphite, okay, and heavy water. Okay, ya, air berat. Heavy water. Okay, ini ada dua bahan moderator yang sangat lazim ditanya. You should memorize this as a set. Kalau moderator, apa gunanya? Apa contohnya? Okay, graphite and heavy water. Since we are talking about moderator, I should also talk about the other one, which is the control rod. Okay, another component satu lagi component dalam nuclear reactor is a control rod. What is the function of a control rod? Okay, is to absorb. Okay, absorb excess neutrons. Okay, dia menyeraplah neutron-neutron yang berlebihan so that it controls the rate of nuclear fission. Okay, and contoh untuk control rod, the most famous contoh is always boron or cadmium. Okay, so remember this as sets of answers because when you know where it is placed, then it's very easy to memorize. Okay, graphite apa, untuk apa dan apa contohnya. Graphite pula. Kalau moderator, okay, moderator, what is the function and apa dia punya contoh bahan. Okay, sama juga, I think control rod is rod pengawal. Okay, rod pengawal, control rod, apa dia punya function dan apa dia punya jenis bahan. You cannot mix this up. Okay, dia memang set sudah begitu. So you must remember it as one set like that. Okay, state the change of energy. Okay, this is what we call sometimes, okay, this is what we call like the super bonus question because this is actually a Form 1 question. Change of energy is something that you learn, actually not even Form 1. Change of energy is something that you learn from standard, like, primary school. Okay, but basically the answer for this is nuclear energy, okay, changes to become heat energy. Okay, and notice that the question is limiting it to the nuclear reactor, not the generator part. Generator is a totally different thing altogether. Okay, but just the reactor part. Okay, the nuclear energy releases a lot of energy in the form of heat. Okay, nuclear energy change to heat energy. All right, next. Diagram 3.2 shows the fission, okay, occurs over here. So you have one neutron and one uranium, okay, and then you release two neutrons, one xenon and one strontium. Okay, so dia ada sebelum dan selepas lah. Okay, so then you're given all these things, okay, all these amazing numbers. Okay, calculate the nuclear energy. First thing we need to know, what the formula involved is E equals to mc squared. Cuma, okay, two things you need to remember. The mass over here is not just any mass, it is the mass defect. Okay, dalam bahasa Melayu it's called cacat jisim lah. Maksudnya baki jisim. Okay, so because what's going to happen is di sini, okay, on the left hand side, you're going to have a certain amount of mass. And then on the right hand side, you're going to have a certain amount of mass, tetapi ada baki. There is some leftover mass yang berlebihan lah. Okay, so that mass is what we call cacat jisim, okay, or mass defect. So if you add this all together, I'm going to put the numbers here, 1.0087. No, I should have done this better. 1.0087 plus the 23592 is 235.0439. Okay, you add this together, you get a certain number. Okay, then you add these four together. Okay, this is 143.9385. This is 89.9077. This is 1.0087. This is 1.0087. Okay, you add all this together. Okay, now when you add all this together, you're going to get a different, you're going to get some balance. Okay, so I'm so sorry, I have no time to calculate all this one by one for you. Okay, but all I know is, okay, let's say I call this number 1 and I call this number 2. Okay, so number 1 minus number 2, I'm going to get the number of 0.189, around there. Okay, This is what we call the mass defect. Okay, cacat jisim. Sebelah kiri tolak dengan sebelah kanan, kamu akan dapat baki. Okay, and that baki is what we call mass defect. But if you notice the unit, okay, the unit is AMU. Okay, UJA atau AMU lah. Okay, unit jisim atom, atomic mass unit. So 0.189 AMU, okay, equals to, we need to change it to kilogram. Okay, so multiply by 1.66 times 10 negative 27. Okay. Oh wow, ada juga yang baru masuk. Okay, 1.66 times 10 negative 27. Okay, which will give you the mass in unit. Okay, so we need to change the mass from AMU to kilogram, and then only you can put it in the formula over here. Okay, so I'm going to put 3 times 10 to the power of 8. Don't forget to square this. Okay, this morning somebody came to see me, asked me a question, totally forgot to square. Okay, so be very careful about this. So when you have done this, your final answer will be 2.82366 times 10 to the power of negative 11 joule. Okay, which you can fill it over here lah. Okay, the formula is an easy formula to remember. Cuma a few things kita kena ingat lah. Satu, we have to calculate the mass defect. Number two, change the mass defect to kilogram. Okay, very rare. Saya tidak pernah jumpa lah soalan yang nuclear reactor bahkan yang dia bagi jisim dalam kilogram. Most of the time, if not all, okay, the answers will be in AMU or UJA. Okay, menjadi tugas murid untuk mengubahnya pergi kilogram. It's your job to change it to kilogram. So change it to kilogram, substitute it into the formula, okay, and then make sure that whatever answer you get, make sure it's in joule. Okay, that's the reason why we change it to kilogram, so that our final answer is in joule. Okay, now if you notice over here, the answer that I've written down, this is from the marking scheme also, okay, the answer that I've written down is full answer lah. So some of the questions that I tend to get is, bolehkah kami bundarkan? Okay, can we just, simplify it lah? Okay, my answer will be, yes, you can simplify, okay, but don't oversimplify it. Okay, I think for me, a safe answer will be a 3 decimal place. Okay, 2.824, okay, times 10 to the power negative 11. I would probably accept this 3 decimal place. 2 decimal place, a little bit, yeah, I wouldn't recommend it lah. Okay, kalau jawapannya panjang betul, minimum 3 decimal place. Okay, I think I mentioned this in the previous class. Either 3 decimal place, okay, atau kalau jawapannya adalah 0.00 something bahkan, then we give 3 significant figures, 3 angka bererti. So there must be a few numbers behind, 3 numbers lah at least. Okay, I think to be on the safe side, we should do that. Especially soalan yang melibatkan gravitation, nuclear, photoelectric theory. These 3, I really advise you don't simplify it too much. Okay, jangan bundarkannya sampai 1 tempat perpuluhan, 2 tempat perpuluhan. It's very risky lah. Okay, because small number, I mean, it looks like, oh, senang saja kalau bundarkan, but actually in reality, all these small numbers actually make a very big difference at the end. Okay, number 4. Diagram 4.1 shows lens S used to correct short-sightedness. Okay, I think this is a very interesting question because when I first saw the question, I was like, whoa, okay, name the type of lens S. This is very easy. Okay, this is a concave, right? Yeah, concave lens. Okay, this is a concave lens. Okay, jangan juga kamu. Don't look at this. Okay, ini lain cerita lagi. Okay, so concave lens. I think that's quite okay. Hold on, somebody wants to join the meeting. Okay, so concave lens based on diagram 4.1 give 3 characteristics on the image formed on the retina. Now, I find this question very interesting because whenever we talk about concave lens, we immediately know, okay, especially if you studied light and optics, I mean, if you like this chapter, okay, concave lens, kita tahu asal keluar daripada concave lens kan, dia mesti virtual, upright and diminished. Okay, dia mesti maya, tegak dan dikecilkan. This is the standard answer for concave lens. But if you notice, the question didn't say based on the concave lens. I say based on diagram 4.1. What's happening over here? The lens S, okay, is doing its job lah. Okay, it's diverging the light out. But after the light diverges out, where does it go? It passes through the eye lens. And our eye lens is always convex lens. Okay, our eye lens is generally a convex lens, which makes this question really, really very interesting. Okay, and this actually brings us back to science, entahlah tingkatan berapa, tingkatan 2 kali, science form 2. Okay, yeah, this is where we have to, like, science form 2. Okay, 3 characteristics of the image form. If you remember how the eye works, okay, the most important thing about the images that enter the eye is that it is always inverted. Ini yang paling penting. Okay, if the tree looks, kalau kita ada pokok macam ni, bahkan at the eye, okay, it looks like this. Okay, it is our brain. Thank you, Liu. Our brain is the one that switches it back upright. Okay, but in reality, our eyes are seeing the world. Our eyes are seeing the world the other way around. Okay, it is our brain that switches it back for us. Thank God for our brain. Okay, otherwise we will be looking at this world like super terbalik. Okay, but this is the most important thing. Okay, it must be inverted. Okay, secondly, because it is captured on our screen, okay, which is at the back of the eye, okay, we call it a real image. Sebab dia dapat ditangkap, okay, at the screen behind our eyes. Okay, and of course, the real tree looks like this, right? Okay, bila dia masuk dalam mata kita, it becomes smaller lah. Okay, so it is diminished. Okay, if you don't understand this, okay, you can watch the video again after this. Listen to this particular explanation. It's a very, I find this question super interesting. Okay, because it tests us beyond more than what we know about concave lens. Kalau concave lens sahaja, we know that it is virtual upright diminished, which is what we're going to do in the next question. We're going to draw it out. But this question is not asking the concave lens. This question is asking what happens after the concave lens, after our eye lens. Okay, bila dia masuk ke belakang. Okay, so actually, even if this lens tidak ada, okay, the picture will still be inverted, real, and diminished, because that's what the image is. Okay, that's what the image form behind our eyes is. Okay, inverted, real, and diminished. Okay, lens S, yada yada. Okay, diagram 4.3 shows an incomplete ray diagram, okay, of an object seen through lens S. Okay, fine. This is a concave lens drawing. Okay, of the 2 drawings that I would recommend you to memorize, because it's very easy, is concave lens and convex mirror. Okay, because this one confirm concave lens and convex mirror, it's always virtual upright diminished. Kau akan tahu ini. Okay, virtual upright diminished. Okay, so for lens, the first line, okay, the first line obviously is the one that runs from top here all the way to the center lah. Okay, this is the first line. Ini memang. Okay, so you can just draw it straight like that. Okay, the second line, okay, the second line is the one where it diverges out, tetapi it starts from the focal point. Okay, start from the focal point here and draw until you reach here and extend it out. Okay, because a concave lens is a diverging lens. And so the place di mana dia berjumpa, okay, tempat di mana dia berjumpa, that's where the image is. Okay, you will get a virtual. Kenapa virtual? Kenapa maya? Because it's on the same side as the lens. Lens, people, lens. Okay, jangan fikir mirror. Mirror is a different story altogether. Lens, if it's on the same side as the object, it's a virtual image. Secondly, dia upright. Dia tetap tegak because it's the same direction as the object. Okay, and finally, it is. Oh, sorry. Okay, finally, it is diminished. Okay, diminished sebab the height of the object begini, the height of the image begini. Okay, dia dikecilkan. So virtual upright diminished, things that you should remember for concave lens are VUD, VUD, VUD. It's the only one that gives you a VUD image. Okay, virtual upright diminished. Okay, so this is how this one will be given lah. So 1 mark for this line, okay, 1 mark for this line, and 1 mark for marking out the image. Yeah, I think that would be the general answer for this lah. Okay, moving on. Okay, the distance of the object from lens S, let me just write down here, first of all, that lens S is a concave lens. Okay, and there's a reason why I want to write this, and I'll explain later lah. Okay, the distance of the object from lens S is 90 centimeters. Okay, so the distance of the object is called the object distance. If you want to calculate the image distance, obviously we need 1 over f equals to 1 over u plus 1 over v. Now, if you remember from the previous class, okay, I said something about this f, u, and v. Okay, I said that if it is a concave lens, okay, and a convex lens, there is a meaning for this one. Okay, concave lens is f is a negative number. Convex lens f is a positive number. This is not going to be given to you in the formula list. You are expected to remember this. Okay, this is one set of things that you have to remember. The other set of things that you remember is the v. Okay, v positive. If your answer for v is a positive number, and if your answer for v is a negative number, it's a very, very important thing. V positive means it's a real image, the image nyata. Kalau V negative, it's a virtual image. Okay, so these two things are very important to remember when you're dealing with this particular formula. Okay, because at the surface, it looks very simple. 90 cm is the U, the focal length is 15 F. Okay, but because it is a concave lens, kita mesti letak the f as a negative value. So this will actually be negative 1 over 15. Kalau kau letak ini positive, your answer will be very different. Okay, which is no. So you have to remember this. Okay, kalau dia adalah concave lens. Okay, if it's a concave lens and if it's a virtual image, be very careful. Okay, equals to 1 over 90 plus 1 over v. Okay, when we move it across, we will get negative 1 over 15 minus 1 over 90 equals to 1 over v. Okay, do the calculation yourself. Flip it over, you get v equals to 12.857 cm negative. Okay, let me write this better. V equals to negative 12.857 cm. Why is it negative? Because it's a virtual image. We know this because we just drew it. Okay, we know it because we just drew it. We know it's going to be a virtual image. Okay, so we expect to see a V negative. Okay, sometimes our students will jawab, then they're like, kenapa ni V negative ini? Then they start panicking. It just means that the image is virtual. That's all it means. Okay, so don't panic. Just make sure that you remember these two sets of information because it's not going to be given to you during the exam. You have to remember this. Okay, what happens to the height of the image if the object is moved away from lens S? Okay, so in this case over here, this object kan kalau saya bawa lebih jauh, okay, this is quite obvious lah. The image is going to become smaller. Okay, so the height of the image is going to decrease. It is standard. Okay, because you move the thing further and further away from the lens, okay, the picture is going to get smaller and smaller and smaller. That's normal lah. Okay, same like if you're going to use a, I don't know, magnifying glass. No, I shouldn't say magnifying glass. Sorry, anyway. The further it is away from the lens, the picture generally becomes smaller, especially if it's concave lens. Okay, number 5. Refraction of water waves when the water waves propagate. Okay, from a shallow region to a deep region. Okay, daripada cetek pergi ke deep. Okay, so just before we begin, a couple of things to remember. Remember that when we're talking about refraction, the frequency is always the same. Frequency tidak berubah. Yang berubah adalah halaju dan panjang gelombang. You can see this lah. Okay, generally, generally deep region is bigger wavelength, bigger wave speed. Yeah. Okay. Shallow region is smaller wavelength, smaller wave speed. Okay. Generally, that's how it works, lah. Okay. So what is the refraction of wave? Refraction of wave is the change in direction or bending. Oh no, wave. Yeah. Change of direction. Okay. Change of wave. No. Change of direction. Okay. Change of direction of wave propagation when it moves uh, between mediums of different densities. Okay. Perubahan ketumpatan yang menyebabkan the change in densities is the one that causes the change of direction of wave propagation. Okay. If you want to make this a bit better, okay, in terms of your answer, also talk about the change in velocity lah. Okay, change of direction of wave propagation when it moves to the that causes ini kalau kamu mau sajalah, okay, that causes a change in velocity. Okay, just to complete the answer lah. Okay, when you change the velocity, when it moves through the mediums, it causes a change in velocity, therefore causing the change in the direction of the wave propagation. Okay. All right. Compare the depth of the water. I think this is pretty easy. Okay. Obviously, the shallow, okay, is smaller than the deep. Okay. Just to remind you, if you're going to answer like this, make sure you give this one. Okay. The depth of the water, then dot dot. Okay. Shallow is less than deep. Always give a title to what you're comparing. Make it a habit because in section C, question 11, it's going to be useful for you. Okay, the wavelength of the water wave, okay, even if you don't know what the wavelength is, you should be able to see it. Okay, this is the wavelength and this is the wavelength. Obviously, the shallow is smaller than the deep. Okay, so the wavelength, shallow, smaller than deep. Okay. Speed of the water wave. Okay, this one have to know lah. Okay, but speed. Okay, the water in the shallow area has a smaller speed. Okay, than the water at the deep area. Okay, this is standard lah. Okay. So after that, state the relationship. So once again, relationship is the bigger the something, the bigger the something. Okay, since we're talking about depth and wavelength, so we know that when you're doing a relationship, make sure the order is very important. Okay, it is the depth that affects the wavelength. Okay, kedalaman yang mempengaruhi panjang gelombang, not the other way around. So kedalaman yang mesti datang dulu. Okay, the bigger the depth of water, the bigger the wavelength. Okay. Okay, for those of you who are not familiar with me, okay, yes, this is how you write a relationship. But moving on from here, okay, I'm just going to use arrow because I usually do this with my students for just discussion practices. Okay, I will just say the bigger the depth, the bigger the wavelength beginilah. Okay, to save time lah. Okay, otherwise most of my time will be spent writing the answers down. Okay, so the bigger the depth, the bigger the wavelength. Therefore, the wavelength and the wave speed is also the same. Okay, if we take a look at this, wavelength and wave speed, because the direction of the direction of the arrow is the same, so it's directly proportional lah. Okay, so I would say the bigger the wavelength, the bigger the wave speed. Semakin besar panjang gelombang, semakin besar laju gelombang. Okay, that's how we would do it lah. Okay. On diagram 5, draw a normal line X. First, you draw the normal line, then draw the direction of the wave propagation. Okay, so remember that a normal line is a 90-degree line. Okay, it's a 90-degree line to the wave front. So what you're going to need to do, obviously, you need to use a ruler for this. Okay, find a 90-degree spot and draw a normal line over here. Okay, it must be 90 degrees to this. Oh, sorry. Yeah, that's the wave propagation block. Sorry. The normal line is here. This is the line, Makan. Okay, so the 90 degrees is here. This is the normal line. Okay, this is the wave propagation. Okay, it's going to propagate this way. Okay, so notice that the wave propagation line, okay, the wave propagation line is always 90 degrees to the wave front, okay, to the muka gelombang lah. Okay, it's always 90 degrees to this. So it's actually not very difficult to remember. But is this a 2-mark question? Hold on. Oh, it's a 1-mark question. Oh no, it's all or nothing. So you have to get both correct lah. Okay, to get this one. That's interesting. Why would they give 1 mark for 2 things? Okay, anyway, 1 mark for 2 things it is. Okay, yeah. So just remember the normal line is 90 degrees to the border. Okay, ini sempadan lah. Okay, and the wave propagation line over here is 90 degrees to the wave front. Okay, yang sedia ada di sana lah. Okay, question E. Given the wave speed for waterways in the shallow region are this. Okay, this is the wave speed V, and this is the wave speed like this. Wavelength in the shallow region is 5 cm. Okay, just double check the units. Everything is in cm, so I think we're good to go. I don't think it's a very big deal. Okay, calculate the wavelength of the waterway. Okay, remember that the frequency at the deep area is equal to the frequency at the shallow area. Okay, every time there is a refraction question, this calculation is most likely going to come up. Okay, our formula is V equals to F lambda. This is the standard formula. The wave equation formula is V equals to F lambda. If I flip it around, F equals to V over lambda. So that means the V at the deep area over the lambda at the deep area equals to the V at the shallow area over the lambda at the shallow. Then kamu boleh gantilah. Okay, the V in the shallow is 10. The lambda at the shallow is 5. The V at the deep is 14. Kita mau cari the lambda at the deep area. Okay, so this will give you lambda of the deep area is 7 cm. Will be the answer to that. Okay, most of the time, yeah, if there's a calculation question for refraction, this is probably the question. They will test you to see if you remember that the frequency of the deep and the shallow area is the same. Okay, so you get V over lambda for that lah. Okay, let me move on. Next, number 6. What time is it now? 9. Okay. Sorry, I'm going too slow. Okay, diagram 6.1, 6.2 show 2 transistor circuits used as automatic switch. Okay, so ada dua switch di sini. Obviously, one the fan is working and the other one the fan is not working. Okay, so this brings us back to the thing that we have to remember lah. Okay, I think if you're my student, you know this. In order for the fan to work your way backwards. Okay, in order for the fan to work, the transistor has to be on. Okay, in order for the transistor to be on, in order for the transistor to be on, the base current must flow. In order for the base current to flow, the base voltage must be big enough. Okay, in order for the base voltage to be big, the base resistance, okay, must be big. This is the flow that you have to remember. Even in explaining, if a transistor question comes out this year, dalam section B or section C, you will need this explanation. Okay, the question then becomes, how do I get the big resistance on the base? Itu saja yang kita kena fikirkan. Okay, that's why we put the thermistor on top. And what is the other one? Light dependent. Light dependent, we put it at the bottom. Okay, because that causes the base resistance to be big, yang menyebabkan the base voltage menjadi besar, yang menyebabkan the arus tapak mengalir, yang menyebabkan transistor switch on, yang menyebabkan your mini fan to work. Okay, so that's the flow of the idea when it comes to the transistor. If you didn't get that, okay, don't worry, you can watch the video again later, and memorize this, because it's a very simple explanation actually. Okay, so what is the function of the resistance at this one? What is the function of this resistance? Okay, the function of that resistance is to control, okay, is to control the base current. Ini adalah set. The reason why we need to control the base current is because if the base current becomes too big, the transistor will boom. Okay, the transistor will meletup, because transistors are very, very sensitive equipment. Okay, sensitive components lah. You cannot have too big of a base current, but you need to have it big enough so that your transistor can switch on. Okay, so it's kind of like Goldilocks and the Three Bears, like, big but not too big, hot but not too hot, cold but not too cold, things like that lah. Okay, so base current needs to be just right, and the function of RB, the base, this RB over here, is precisely that. Okay, dia punya fungsi adalah untuk mengawal atau mengehadkan, okay, itu arus tapak. Okay, to limit the base current, to control the base current. Okay. 6.1, 6.2, compare the position of the thermistor. Okay, notice that we seem to notice this a lot, okay, especially Australian students. We've seen this question happen many times. One question will be, one is bigger than the other. Then you got this one very strange question. They ask you to compare the position, okay, which is like, bukan satu lebih besar daripada satu lagi, just compare position saja. So how do you write the position of the thermistor? Okay, 6.1 di atas dan 6.2 di bawah. Okay, not really lah. Okay, you shouldn't be writing it one on top, one on bottom lah. It's kind of ambiguous. But what we know is that this part over here, this is called the base circuit. Okay, litar tapak. That's what you call it. It's called the base circuit. So what you should be writing is 6.1 is above the base circuit. Manakala 6.2 is at the base circuit. Okay, don't write above, below, don't write on top at the bottom. Not a good idea. Okay, either you're at the base circuit or you're above the base circuit. I think that's a bit better. Okay, the word base circuit should be there. Litar tapak harus berada di sana. Okay, yes, I know this is not a very cantik answer. What you should be writing is the thermistor in, I know. The thermistor in 6.1 is above the base circuit, manakala 6.2 is below the base circuit. At the base circuit. Okay, state the circuit that has a higher base voltage. The circuit that obviously has a higher base voltage is 6.1 lah, because the fan turns on. Okay, so diagram 6.1. Okay, now which circuit causes base current to flow? Obviously, also the answer will be diagram 6.1 lah. Okay, now this is actually very easy. Okay, if this explanation that I'm showing you over here makes sense. Okay, this is the basic explanation for transistor. Okay, when the base resistance is big, the base voltage is big. When the base voltage is big, base current will flow. When the base current flows, transistor will on. When the transistor ons, then the fan will turn on. Okay, I highly recommend lah. Okay, memorize this. It's like a 5-step program lah, because they must ikut itu. If this happens, then the next thing must happen. This happens, then the next thing must happen. This happens, then the next thing must happen. Okay, kind of like computer programming lah, If this happens, then just pop, macam tu. Okay, stop membebel. Okay, relate the position of the thermistor, okay, and the base voltage. Okay, so remember when you're comparing, you must mention both diagrams, but when you are not comparing, when you're relating, you mention one diagram itself is good enough. Okay, so when the thermistor, okay, is at the base circuit, maksudnya yang di bawah lah kan. Okay, when the result is at the base circuit, the base voltage BB is high. Okay, dia adalah tinggi, because that's what we have over here. Okay, voltan tapak yang lebih tinggi. So kalau dia punya thermistor berada di litar tapak, okay, then the voltan tapak. Okay, base voltage is high. Okay, dia tinggi. Satu cukup, satu hubungan cukup. You don't have to mention the other one. Cuma dalam comparison, memang kamu kena mention lah. Okay, you have to mention both the diagrams. Okay. Okay, relate the base voltage and the flow of base current. Okay, so this is actually talking about these two. When the base voltage is high, base current flows. Okay, we cannot run away from this explanation. Okay, when the base voltage is high, base current will flow. Okay, so my students in All Saints, we had one class specific for this, and saya paksa kamu untuk hafal benda ni balik-balik. This is the reason why. Because it's once you know the explanation kan, then whatever answer you give kan, dia mesti berdasarkan jawapan itu. Okay, so that 5-step program lah, please remember and commit it to memory. Okay, because it's very useful, especially this is the second time. I think this is the second time, kan? This is the second time we're seeing a transistor question come out in structure. Okay, the other day when we were doing Terengganu pun keluar, this time also keluar. I think it's a good indicator for us, okay, to kind of focus on this subtopic lah. Okay, all right. Based on diagram 6.1, the potential difference across the 10 kilo ohm resistor must be at least 4 to switch on the mini fan. Okay, let's mark this down first. 6.1 okay, dia cakap di sana, dia punya voltan di sini mesti 4 volts. Oh, sorry. 10 kilo ohms. That's what I said, right? Yeah. Okay. Must be at least 4 volts. So dia cakap calculate the resistance of the thermistor. Okay. So kalau sini adalah 4 volts, the total over here is 6 volts. Very logically, you should know that this is 2 volts. Okay. Why? Because dia adalah pembahagi voltan. Okay, litar ini adalah litar pembahagi voltan, potential divider circuit. Okay, so kalau 4 itu sudah kena bagi dengan 10 kilo ohm, itu thermistor dia terpaksa ubah supaya hanya 2 volt saja yang boleh masuk. Okay, from this you can calculate the resistance of the thermistor. Okay, so if the resistance of the thermistor is the one that you want, put the resistance of the thermistor on top. Okay, over the total resistance. Total resistance is RT plus 10. Okay, don't worry about the kilo ohms. It can be in ohms or kilo ohms, doesn't matter. Leave it as kilo ohms also can. Okay, equals to how much is the thermistor voltage? 2 over how much is the total voltage? 6. Okay, yang kamu mau per the total. Yang kamu mau punya voltan per the total. Okay, this is what we call the potential divider formula lah. Okay, actually it's just very, very basic. Nisbah dan perkadaran. Okay. Anyway, when you're done with the calculation, you will get RT equals to 5 kilo ohms. Okay. Actually, you didn't even need to change. Tidak perlu pun tukar itu 10 kilo ohm pergi 10,000. You can leave it as 10 kilo ohms. It's fine. Okay. As long as your final answer is 5 kilo ohms. Jangan juga 5 ohms. Okay. It's a bit too small. Yeah. Okay, so RT over RT plus 10 equals to 2 over 6. You just kira-kira, you get RT equals to 5 kilo ohms. Okay, the mini fan is replaced with a 240 volt and 40 watt fan. Okay, what will happen to the poor fan? Okay, so you want to replace the mini fan, okay, that only needs 6 volts to function. Okay, you want to change it to 240 volts. Okay, and with a much higher power lah. Okay, with a much higher power, what will happen to the fan? Okay, the fan will not switch on. It's pretty basic one. Okay, or the fan will not function. Yeah, the fan will not function. I think it's also an okay answer. Basically because the fan's demands are too high. Transistor, it's such a small and delicate equipment. Okay, 6 volts saja kamu perlu. Ini mau 240 volt, baru dia boleh berpusing. It cannot function. Okay. All right, number 7, hydraulic chair. Remember that when you see the words hydraulic, this is Pascal's principle. Okay. This is the only time we see Pascal's principle whenever it's hydraulic now. Okay, so, well, here we go. Pascal's principle. Okay, involved in diagram 7. I think this is not that difficult. So Pascal's principle formula is F1 over A1 equals to F2 over A2. Okay, janji kamu punya unit semua sama kan, then it's not an issue lah. Okay, tidak payah tukar pergi SI unit atau apa-apa because ini adalah formula perkadaran. Okay, so the cross-sectional area of the input piston is A1. Okay, cross-sectional area of the input piston is A1. And the cross-sectional area of the output piston is A2. Okay, so sini adalah A1. Ini adalah A2. Okay, the weight of the chair is 2000 newtons, while the force exerted on the input piston, so this is F1. Okay, question is calculate the maximum patient. Okay, maximum patient pula. Calculate the maximum patient weight. Okay, the weight of the patient, which means that kalau ada orang duduk di sini, okay, yes, this is me drawing. Okay, kalau ada orang duduk di sini, ada dua beban lah bahkan. One is the weight of the chair and one is the weight of the man. Okay, so our F2 becomes the weight of the chair plus the weight of the man. Okay, so kalau kita ganti ke dalam formula ini, okay, you get 150 over 75 equals to the weight of the chair is how much? 2000 plus the weight of the man over 1500. Okay, using this formula lah, F1 over A1 equals to F2 over A2. Okay, do the calculation. I think it's a very simple calculation. You get W, the weight of the man, is about 1000 newtons. Okay, I don't think this is it's not particularly difficult lah. Okay. Okay, table 7 shows the characteristics of 3 different hydraulic chairs. Okay, so you have all this value of the multiplying factor. Multiplying factor means the F, I mean, kalau nombornya lebih besar, maksudnya itu daya akan berganda. The force will multiply. Okay, if it's like this, a small number, the force won't multiply, dia akan berkurang. Okay, so we want to have the appropriate characteristics of a hydraulic chair that can lift heavier patients. Okay, ini tujuannya. Kita mau angkat yang lebih berat. So the multiplying factor must be a big number. Okay, or large number lah. Okay, which is this. Okay, this is a large multiplying factor. Sebab coba katakan saja 1600 bahagi 70 berbanding dengan 70 bahagi 1600. Obviously 1600 bahagi 70 lebih besar nomornya. So it's a bigger multiplying factor. Okay, the type of hydraulic fluid ini kita mesti tahu. We always use oil and the answer is pretty standard for oil. Okay, sorry. Big multiplying factor so that you can get a large output force. Ini standard. Okay, daya output yang besar. We use oil. The standard answer for oil is because it's incompressible. Okay, tidak boleh dimampat. Okay, either tidak boleh dimampat atau difficult to form air bubbles. But recently I heard that we cannot use the word difficult to form air bubbles because the better word is incompressible. Tidak boleh dimampatkan. Itu jawapan yang lebih cantik. Okay, so I suggest that, yeah, incompressible actually is a nice answer. Okay, makes us sound smart also. Okay, so based on this one, obviously the one that we want is K lah, because if you do the table analysis, K saja yang memenuhi kedua-dua. Okay, so reminding you once again, whenever you do question number 7 and number 9, number 10, analyze the table first before writing down the answer, so you kind of know you have a direction to go. Okay, number 8, worker pushing a wheelbarrow with a force F. The frictional force acting on the motion of the wheelbarrow is Fr, okay, to the back. So what is meant by resultant force? Resultant force is the total, right? Total, yeah. Oh no, yeah, a single force, sorry. A force lah, no, a single force? Yeah, a single force. A single force that represents the sum. The sum of two or more forces. Wow. Mana juga orang yang mau masuk sekarang. Okay. Two or more forces acting on an object. Okay, satu daya yang mewakili jumlah, hasil jumlah semua daya yang bertindak ke atas satu objek tersebut. Okay, that will be resultant force. Okay, given the force F is 100 newtons, calculate the horizontal component. Okay, so in your diagram over here, this is 100, okay, and this is the horizontal component. So let me draw this for you. If this is the sengit yang daya yang sengit, maka semua daya yang sengit boleh dipecahkan kepada dua komponen. Satu komponen mendatar, satu komponen menegak. So you have a horizontal component and a vertical component, okay, komponen menegak. And usually there's an angle given, okay, so dalam case ini sudutnya adalah 60. Okay, now usually when I teach my students, I tell you all, look at where the angle is. Kalau angle itu menyentuh that particular this one, ini akan menjadi cos 60. Okay, then ini akan menjadi F sin 60. Why? Because we learned last time that cos equals to adjacent over hypotenuse. Adjacent to bersebelahan. Okay, the line that is next to the angle is the cos. Manakala sine is opposite over hypotenuse, kan? They're opposite. So that's why this one is sine. Okay, everything depends on where you put the angle. Okay, sorry, I got no time to go into this, but anyway, the horizontal component is this. So Fx equals to F cos 60. 100 cos 60 will give you 50 newtons. Okay, these 2 marks is pretty easy. 1 mark here and 1 mark here lah. I think this should be okay. But yeah, it's not a very particularly difficult question lah. Okay, cuma kau kena ingat sajalah mana satu yang cos, mana satu yang sin. Tengok itu sudut betul-betul. Look at the angle. Okay, whichever one that the angle is touching, that's the cos. Okay, dia boleh bertukar itu. Sometimes they can give you yang di sebelah sini, yang di bawah itu. Okay, yang angle. Sure, jadi yang di bawah lah yang jadi cos. Okay, structure of a wheelbarrow, you are required to suggest modifications so that the wheelbarrow can be easily moved forward faster. Now, there's a reason kenapa saya balik-balik saya highlight ini. Just to remind you that you cannot use this as your reason. Tak boleh. Okay, you have to figure out something else for the reason. Okay, so please don't copy back the question as an answer. Okay, the angle of theta, okay, the angle of theta, and this kind of reminds me of when I was doing this class with, was it 5S1, the one that we asked Chung Yi Chen to go on the wheelbarrow. Okay, anyway, so the angle, yeah, the angle must be small. Oh no, I think that was so traumatic. Okay, anyway, the angle must be very small. Okay, not very small. Okay, the angle is small so that you can get a bigger horizontal component. Okay, bigger horizontal force or bigger acceleration also can, because you want it to move forward faster. Okay, another way of saying faster is bigger acceleration. Wow. Okay, as long as you don't use the word faster. Okay, I will never be able to look at the wheelbarrow the same way again. Okay, anyway, the length of the handle should be long. Okay, a longer handle is always much better. For the exact same reason. Okay, bigger horizontal force, bigger acceleration. I suppose if you want to say bigger resultant force also can lah. Okay, the idea is there lah. Okay, a long handle, okay, gives you a much bigger this one. Actually, a longer handle gives you a smaller angle. Smaller angle gives you a bigger horizontal force lah. Okay, so I think either way is fine. Okay, so also to remind you all, don't forget you can give the same reason. Okay, for different characteristics is totally fine. Cuma dia punya sebab walaupun dia sama, dia mesti berkaitan. Okay, don't give a random reason yang tiada kaitan langsung lah. Okay. Oh, there's one more, sorry. The density of the wheelbarrow. Okay, I think this is like a bonus question. Okay, ketumpatan kredit. Who would want to carry a heavy wheelbarrow? Sudahlah benda yang kamu mau angkat itu kan berat sudah. Lepas tu kamu mau lagi wheelbarrow yang berat kan? It doesn't make sense. So the density of the wheelbarrow should be small. I think this is ini memang small or small density lah. Okay, why? Okay. So the standard answer, okay, for small density, we always say so that whatever it is lighter. Okay, small density container, so that the container is lighter. Okay, and yes, I'm pretty sure that the answer for lighter is correct lah. Memang tidak salah. Okay, cuma saya khawatir because somebody told me once that I think lighter is like too simple of an answer. Macam kalau budak form 5 kan guna jawapan lighter kan macam terlampau senang lah. Okay, so let's make it a little bit more physics lah. Okay, instead of saying lighter, I suggest say smaller mass. It's like this big anticlimactic answer lah. Okay, smaller mass, yeah, smaller density generally means smaller mass. Okay, and because you have a smaller mass, I'm just going to go a little bit forward. Bigger acceleration. Okay, because at the end of the day, we still want the wheelbarrow to move forward faster. So, bigger acceleration, I think that's fine lah. What's the time? 24. Okay. This is probably going to go a little bit late because there's one very interesting question in this paper, and it is this question. Okay, so I'm just going to carry on now. Okay, what is the meaning of specific latent heat of vaporization? Sorry, if you're not familiar with this question, is cotton ball, put in alcohol, then sejuknya, okay, that feeling lah. So, the specific latent heat of vaporization is the quantity of heat. Okay, quantity haba yang diperlukan, quantity of vaporization, quantity of heat needed, okay, to change liquid to gas. Vaporization makan, yeah, liquid to gas for 1 kg of an object. Okay, without, this is the most important statement, without a change in temperature. Ini mesti disebut tanpa perubahan suhu. Okay, no change in temperature, change from liquid to gas. I suppose you can say vice versa also lah. Okay, but generally this would be the answer that you want. Okay, how much heat you need to change between liquid to gas without a change in temperature. Okay, there are a few variations of this definition. Okay, but I think the keywords are in the answer that I gave you lah. Okay, this is the interesting question. When a cotton ball is soaked with cold water, in this question is soaked with the isopropyl alcohol liquid lah. Okay, and we know that when you put it in alcohol, dia cepat meruap. Okay, it evaporates very fast. But this question is, when the cotton ball is soaked with cold water, okay, sebab kita mau sejuk makan, okay, applied to the same skin area, it is found that after a few seconds, the water does not evaporate like alcohol. It remains there. Okay, this is observation number 1. Okay, after a few seconds, the water does not evaporate like alcohol. The second observation is the cooling effect is smaller. It is not as cold as alcohol. The question, I love this question. Okay, after the long explanation kan, terus dia tanya, explain. Begitu. Kan macam, macam sombong sangat on this question. Kan, explain. Terus macam tu. Kan, like, a little bit biadab lah bahkan. Okay, so we have to explain these two situations. Okay, number 1, kenapa, why is it that the water doesn't evaporate very fast? Okay, and this is where we need to use the specific latent heat of vaporization lah. Okay, alcohol has a smaller specific latent heat of vaporization. It vaporizes very easily. Okay, that's number 1. Secondly, we also have to explain why is the cooling effect of cold water smaller. Okay, why is it that when alcohol, when alcohol evaporates into the air, okay, it leaves a very cooling effect because it absorbs a lot of heat lah. Okay, so this is a very, I love this question, okay, because it's very interesting. Okay, but it's also, a bit difficult to explain, especially if you're not used to, wah, ada dua benda pula yang saya kena explain. Okay, so let's begin in the yellow lah. Okay, I'm going to start the yellow part over here. Okay, the first thing that you need to say is, why is it that the water does not evaporate like the alcohol? Okay, because alcohol, okay, has a lower specific latent heat of vaporization. I think it's like lower by 1,000 times, Alcohol is like 10 to the power of 5 and water is like 10 to the power of 6. Oh, no, sorry, 1,000 times, like 10 times. Okay, anyway, alcohol has a lower specific latent heat of vaporization than water. Okay, so that's why it vaporizes very easily. Okay, it absorbs heat and vaporizes or evaporates lah. Let's not say vaporizes lah, evaporates. Okay, easily. Okay, giving the cooling effect. Okay, let me move on to the pink color. Okay, astaga, sorry. Pink color. Okay, the pink color is talking about the cooling effect. Why is it that the cooling effect? Wow, it's almost 10, but baru Farisha masuk. Okay, so why is it that the cooling effect of cold water, okay, is smaller? Why is it like, cold water not as cold as alcohol? Okay, we need to remember this. In order for it to vaporize, sebelum anything vaporizes, it has to reach a certain temperature. It has to reach the boiling point. Okay, boiling point of water is 100. Boiling point of alcohol is way lower. It's much lower. It's very easy for alcohol to boil. Right. Yeah, I think so. Okay, and therefore the water sebelum dia boleh evaporate, it has to reach like, a certain temperature, 78, I think, okay, before it evaporates. And as it does that, okay, it's absorbing what? Specific heat capacity before it can absorb the specific latent heat in order to vaporize. So it's a very long process for this lah. Okay, so just to keep it short, okay, the reason why the cooling effect of cold water is smaller is because water has to absorb a lot of heat before, a lot of specific heat capacity. Okay, before, I know the answer sounds a little bit weird, specific capacity. Okay, water has to absorb a lot of specific capacity before reaching, sorry, actually not, before evaporating. Okay, so it absorbs a lot of the heat the heat from the skin, okay, that goes into the water is used to raise the temperature of the water. And because it's not evaporating, yeah, I know. Actually, yeah, Timothy, it should be, okay, the reason why I say specific capacity is because the reason why it has to, this one is because it has, before it can evaporate, it has to reach a certain temperature, then it can evaporate. Okay, I mean, we know that lah. So, for alcohol, because the boiling point is so low that it kind of immediately evaporates by just a little bit of heat, just takes the specific latent heat lah. Okay, but the reason why I'm putting it as specific capacity is to distinguish what is happening between alcohol and water. For alcohol, very little specific heat capacity is needed to be absorbed because it's almost at the boiling point already. All they have to do is just push into the air. Okay, so most of the heat that's absorbed is the specific latent heat, vaporizing and then leaving a cool place lah. Whereas for water, it has to absorb the specific heat capacity to get to a certain temperature, then only it can vaporize. Specific latent heat. Okay, specific latent heat absorbed is more than specific heat capacity. That's why the cooling effect of the alcohol is much bigger, because okay, water specific capacity is 4,200 units. It's like two zeros at the back. But alcohol specific latent heat is 10 to the power of 5, Okay, this is a big number, 10 to the power of 5. So it's a lot more heat absorbed just to evaporate. Okay, so the combination of the low alcohol boiling point and the high specific latent heat to evaporate gives us that cooling effect, because a lot of heat is absorbed for it to vaporize. Kalau air, it absorbs a little bit, 4,200, 4,200, 4,200, then it reaches a certain level, and then only it can evaporate away. Okay, so in that short amount of time, okay, the cooling effect of the alcohol is more significantly felt. Of course, I suppose if we are talking about like, in the span of 15 minutes, okay, ini memang, this is way off tangent than what we're supposed to be talking about. But if we're talking about 15 minutes, sure, perhaps in 15 minutes, the cooling effect of the water is more significant, which is actually true, because specific latent heat of water is much, much higher than alcohol. But right now, in our case of a few seconds, that few short seconds where we have the alcohol and we have the water, we find that alcohol has a more lasting cooling effect. Because in that few seconds kan, first kamu mau kasih naik itu air punya suhu, baru dia boleh tersejat. Okay, so there's not much heat that's absorbed there, because you can't even get to that evaporating point yet lah. But alcohol, sure, serap saja, poof, evaporate. TLDR, it takes more heat energy for alcohol to vaporize than for water to rise in temperature in that short time frame. Correct. That's the one. Okay, because the keyword is in a few seconds. Okay, I have to be honest with all of you who are listening or watching this. Okay, this is a very non-routine question. Okay, kalau kamu rasa, oh my goodness, I'm going to fail physics, don't think that way. Okay, this is a very once in a lifetime. Okay lah, once in your lifetime kind of question lah. Okay, it's so rare to see these kind of questions, but it's a very good question. Saya suka soalan macam ni because it makes me think. Okay, it makes me think out of the box lah. I cannot find this answer in a book. Okay, I had to think about it and try to explain it. Okay, which is what our class is a little bit. Okay, tapi yeah, but this is not a routine question. Okay, if you find that susah betul kamu mau fahami ini, it's okay. Focus on the things that you can do. Okay, which is the next question. Okay. Okay, autoclave in a laboratory that is used to kill germs, and this is basically a pressure cooker. Okay, periuk tekanan lah, ini macam biasa saja. Okay, si Haidar masih ada ke di sini ya? Okay. So the basket filled with laboratory apparatus is put into autoclave to be sterilized. Okay, the airtight lid, etc., etc. Okay, the power of the heating element is 500 watts. If in a heat question, kamu nampak saja watt, kamu nampak saja ini, remember that energy is power times time. Cuma time ini mesti dalam seconds. So your first job is changing this to, the 15 minutes to seconds, okay, which is 15 kali 60. Okay, so the heat supplied is the energy. Energy equals to 500 times 15 times 60. Okay, tukar massa kepada saat. This is very important, which will give you 450 joules. Okay, masih cikgu. Okay, nice. Okay, the heat in 9C1 is used to change water. Okay, so calculate this one. Wait, there's no question over here. Oh, calculate the mass of the water. Okay, so this is E lah. I'm going to use E for energy. Energy equals to MC delta theta. Okay, pertukaran this one. Okay, the mass. Oh, wait, hold on. Water 2500 steam. Oh, wow. Okay. So there's two energies over here because saya nampak di sini ni. First, they give you the specific heat, then they give you the specific latent heat. So there's two involved. One is E equals to ML, One is E equals to MC delta theta. Okay, so the M is what we want to find. Okay, this is C is 4,200. The delta theta is 100 minus 25. Okay, on this side, the energy M and then the L is 2.26 times 10 to the power of 6. Okay, jumlah kedua-dua ini, okay, is equals to 450,000. Because 450,000 yang kita kira sebelum ini. Okay, so 450,000 equals to M times 4200 times 100 minus 25 is what? 75. Yeah, 75. Okay, plus M times 2.26 times 10 to the power of 6. Okay, bila kau kira-kira, you will get M equals to 0.175 kilograms. Lebih kurang beginilah. Okay, so copy down the answer first, then take some time and go through this one. Okay, this is a particularly difficult question, I understand. Okay, sudah dia punya explanation difficult, lepas itu dia punya pengiraan pun one kind. Okay, but you know, just go through it and see and try to understand it lah. Okay, after a while you will notice that it's not that difficult actually. Okay, 4 types of autoclave, JKLM, different specifications. Anda dikehendaki mengkaji kesesuaiannya untuk sterilization of laboratory that can be carried out quickly and safely. Wow. Okay, so the number of locks. You know what the locks are used for, right? The locks are used for sebab ini adalah macam periuk tekanan. It's like a pressure cooker. So the locks are used to keep the lid in place supaya itu penutup itu tidak terbuka. Okay, I mean, you know, like have you ever cooked Maggi bahkan then kau tutup itu and then suddenly the water boils kan, the penutup also blub, 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 begitu. So the number of locks is more. Okay, we want more number of locks. The reason for this is something to do with pressure. Wait, I'm having a brain fart. The lid lah. Okay, the lid does not open. Yeah. Okay, when open, when it is heated. Yeah. Okay, or the steam is not released. Oh yeah, actually the steam is not released is better. Okay, steam is not released when it is heated. Also can. Either way lah. Okay. Now, safety valve, obviously you want a safety valve, okay? Mengundang, okay, the reason for the safety valve is to release excess steam, because after a while you don't want the steam anymore, so you use the safety valve to open it and release it slowly. Okay, the power of the heating element should be high because you want this to be, you want this job. The job of the autoclave, remember, the job of the autoclave is to kill the germs and viruses. So we don't want them to slowly die. The poor germs and viruses, just kill them off as fast as you can by giving a high, high power lah. Okay, so more heat supplied is the standard answer. Okay, lebih banyak haba dibekalkan. Okay, the wall has to be thick. Okay, kalau kamu nampak sudah pattern kan, you know that we are going towards M. Okay, so the wall is thick to be able to withstand. Okay, withstand high pressure. Okay, reminding you once again that this is a 10-mark question, answer in the form of a table. Remember the 9th and the 10th mark. Okay. If you don't know what I'm talking about, please go and ask your teacher. I'm very sure that all the teachers will know this now. Okay, the 9th and the 10th mark. Make sure that you write it out. Okay, don't just say, oh, because it fits all the characteristics above. Okay, question number 10. Oh, we're running out of time. Okay, dry cell electromotive force of 3.7. This is the first time I'm seeing a battery with an electromotive force of 3.7. But sure, okay, let's assume that this will exist. Okay, what is electromotive force? Electromotive force is the work done. Sorry, the work done, okay, to move 1 coulomb of charge uh, 1 coulomb of charge in an open circuit. Okay, the work done to move 1 coulomb of charge in an open circuit. Okay, since we are on this topic, okay, I also want to say the potential difference. Okay, potential difference has almost the same definition. The work done to move 1 coulomb of charge between 2 points. Okay, the definition is almost the same, just like what we did at the first question, determining emission and photoelectric effect. The words are very similar, cuma dia punya hujung-hujung saja yang lain. Okay, so kalau electromotive force, kalau daya gerak elektrik, kerja yang dilakukan untuk menggerakkan 1 coulomb charge di dalam 1 liter terbuka. Okay, the only difference is just these words only. Okay, potential difference, beza keupayaan, kerja yang dilakukan untuk menggerakkanlah, okay, untuk menggerakkan 1 coulomb charge antara 2 titik. That's it. Okay, the dry cell is used as experiment, the arrangement. So remember this dry cell is 3.7 volts. What a strange EMF. But sure, fine. Okay, when the switch is closed, okay, the voltmeter reading is 3 volts, ammeter is 0.5. Isn't it complete circuit? Sorry, we're in the complete circuit. Oh, wait. Oh, yeah, sorry. Complete circuit. What did I say? Open circuit. Sorry. Complete circuit. It should be closed circuit, right? Yeah, it should be closed circuit. Why did I say open circuit? Okay. Thank you, Naveen. So when the switch is closed, voltmeter reading becomes 3.0. Okay, so this 3.7 magically becomes 3.0 when it is when the switch is closed. Okay, ammeter reading is 0.5. So the question is, the voltmeter reading when the switch is closed doesn't show the same value as the EMF. Okay, and we have this question again. Explain. Oh, I just love this question. Okay, dia cakap saja explain macam tu. Okay, doesn't tell us in this one. Okay, so why is there a change? Okay, why is there a change in the voltmeter reading when it is this one? So 4 marks, 2 markah cakap pasal liter terbuka, okay, open circuit when the switch is open. 2 marks talk about when the switch is closed. Okay, so the first mark, okay, when the switch is open, okay, the reading shows the EMF of battery. Okay, when the switch is closed, the reading shows the potential difference of the circuit. Okay, so dia menjadi 3.0. So what happens there is a voltage drop. Okay, and you have to explain why there's a voltage drop lah. Okay, there's a voltage drop due to the internal resistance of the battery. Okay, yeah, I think it's good enough. When the switch is open, the reading shows the EMF of the battery. When it's closed, it shows the potential difference of the circuit, but there is a voltage drop. Okay, actually, this is the 4th point. The voltage drop is because of the internal resistance of the battery. Okay, all right. Calculate the internal resistance. Internal resistance is due to the voltage drop. Okay, so originally 3.7 is the EMF. Okay, the voltage is 3. So the voltage drop, usually saya tulis VD lah, dia punya voltage drop is 0.7. Okay, voltage drop is equals to I times small r, which is why we can get the small r, because are we given? Yeah, is 0.5 amps. Okay, so 0.7 equals to 0.5 times r, you get r equals to 6. Oh no, sorry, not 6. R equals to 1.4 ohms. Okay, you can calculate the resistance of the bulb because you know that this one, okay, V equals to IR yang biasa. So 3 volts equals to 0.5, and you can get R, so R will be 6 ohms. Okay, I think this is a pretty okay lah. This is a simpler okay, simpler question lah compared to the heat question just now yang kita terlalu lama. Okay, identical bulb is connected in parallel with the bulb in diagram 10.2. Okay, state the change that occurs due to the emitter reading. Sorry, state the change that occurs to the emitter reading. If you, okay, so let's look at it logically. If I have one more bulb over here connected in parallel, what's going to happen is that my resistance, my total resistance is going to decrease. Okay, since my voltage remains the same, it still will be 3. Okay, so what's going to happen to my current is going to increase. Okay, because my total resistance has decreased. Whenever I add more and more things in parallel, the total resistance decreases, the effective resistance decreases, which gives me a better current flow. Okay, there are times where we need to have series, there are times where we need to have parallel. Okay, but this is just one of that. Okay, where we have parallel. Okay, electric vehicle. Okay, this is this is kind of a hot topic nowadays. So we want to have 4 kinds of batteries. Okay, battery RSTU. Okay, the most suitable battery to move the electric vehicle fast and efficiently. Okay. Thank you for hanging with me there. Okay, just a while more. I will try to finish by 10-15 maximum. Okay. So let's go for this. The type of battery nowadays, especially in EV cars, okay, we go for dry cell. Okay, we go for dry cell mainly because it is low maintenance. I know the word low maintenance is like, where is the physics in low maintenance? Okay, yes, there's a lot of physics in low maintenance, but we're not going to get into that. Another one, which when I was looking at the marking scheme as I was checking this, it says lighter. Okay, which is, well, yeah, I guess it could be because there's not a lot of liquid so it's probably lighter. It's a very strange answer to give. I would rather go with low maintenance Okay, electromotive force, of course, it must be bigger Why would you carry around a power bank with a small mAh? Okay, so you want to have a much bigger electromotive force so that you can supply more energy. Okay, or supply more current. Either one also can Okay, the mass of the battery, this is a no-brainer. The mass should be low to increase acceleration. Okay, and the arrangement of the battery, okay, this is very important. You want to have a high-powered car. You want to have big EMF. Okay, so if you're looking at this, you're obviously already going to choose T. Sebab 3 daripada 4 kau sudah pilih. Okay, so we're going to go for series arrangement. Okay, the main reason for series arrangement is not to protect the car in a sense, okay, but it's so that you have high EMF. Okay, because high EMF means you will have a much better supply. Okay, kind of like a torchlight when you put the torchlight, you put the batteries in series, right? That's why your lights become brighter. Imagine if you have a torchlight and all your batteries are in parallel. Okay, you're gonna have such a dim light Okay, so having in series so that you have high voltage or high EMF. Yeah, you can also write high voltage. I don't think that's an issue. Yeah. Okay. One final reminder, 9th and 10th mark. Okay, please don't forget this. Okay, let's finish this. One more question. Okay, one more question. Hang in there, people. Hang in there. Okay. I've lost half the people that came in just now, but thank you for staying. Okay. Okay, 11.1, 11.2 show the arrangement of apparatus used to study the effect. Okay, rod AB moves at a distance where current I flows in the rod. This is, you know that it's going to happen lah. Okay, state the rule for determining the direction of the motion. This is left hand, right? Yeah, Fleming's left hand rule. Wait, yeah, left hand. It should be left hand. Okay, so Fleming's left hand rule. Okay, compare the current. Okay, let's take a look. One thing. The second thing to compare is the distance. The third thing to compare is the force. Okay, three things to compare. And then kalau relate the current to the distance. And then after that, I'm running out of colors, sorry. Relationship between distance and the force. Okay, there are always 5 things there because this is a 5-mark question. So don't lose sight of the fact. Okay, compare the current. If you take a look at this, one is 6 volts and one is 12 volts. I know it's voltage, but logically, if there's a bigger voltage, there's going to be a bigger current. So 11.1 is, smaller than 11.2. Okay, just to remind you, in essay question, especially like this, make sure you write your answer like this. Okay, current diagram 11.1 is smaller than 11.2. If you're going to use symbol, make sure that it's a title for the thing that you are comparing. Okay, the distance of the current carrying rod, this one will also be 11.1 is less than 11.2. Okay, tengok ini huruf D pun kau tahu sudah, 11.1 smaller than 11.2. Okay, and then finally the force. Okay, since the distance is more, obviously the force is also more lah. So 11.1 is less than 11.2. Okay, relate the current to the distance. The bigger the current, the bigger the distance. Saya bagi short form saja, nanti kamu write the full answer on your own. Okay, finally, relate the distance and the force. Okay, notice the question. The question asks distance first and then force. But if you think about it, it is the force that causes the distance. So it must be the bigger the force, the bigger the D. Okay, I'm going to put a star in this question. Okay, just to remind you that the order of the relationship is very important. The bigger the force, the bigger the distance. Don't switch it the other way. Okay, be very careful about this. Okay, simple electric motor using several batteries. Okay, this is electric motor. In our previous class, we were looking at DC generator. Okay, the people who have been with me since the first session on Saturday, this is the second time we are seeing an electromagnetic question in essay. Okay, it's kind of an indicator lah. Okay, it's not 100% ramalan. Okay, but I think it's a good idea to memorize these things that we've been talking about. Okay, in case it comes out. Okay, because twice already we are seeing this. Dua kali sudah kita tengok transistor, dua kali sudah kita tengok ini, motor generator. I think it's a good indicator. Okay, DC generator, I think this is a very simple explanation. Oh, ini pula yang dia sangat sopan santun. Explain how the copper coil can rotate. Okay, so this is a standard answer. I think those of you who have the black book, you will know this. Okay, current flows. Current flow in coil and produces a temporary magnetic field. Okay, then the magnetic field of coil interacts with magnetic field. Okay, catapult field is produced. Okay, two forces with opposite directions. Sebab kamu mau rotating coil bahkan. Rotating coil means one go up, one go down. So two forces with opposing directions are produced and rotates the coil. Yeah, something like this. Okay, two forces opposite directions produce rotate the coil. I think this is okay. 4 marks. Okay, last question, last question. Okay, let's hang in there. Okay, 10 o'clock. Okay, so we can end a little bit early. Okay, homopolar motor. We have not seen this question. This question is in your textbook. Okay, we always talk about this homopolar motor, but we have not seen a question like this in SPM yet. Okay, so in case it's your lucky year, it's a good thing we're discussing this. Okay, so you are required to modify the simple homopolar motor so that it can spin faster and longer. That's basically what we want. Okay, spin faster and longer means you want to have a bigger bigger catapult field, bigger force lah. Okay, bigger force so that it can rotate faster. So you are given how many things? Type of dry cell. Number 2, number of dry cells. Number 3, number of magnets used. Oh, all 5 are given. Number 4, the connection. And number 5, I'm running out of colors again. The characteristics of wire. Oh, this is such a kind question. They give you all 5. Okay. I think this is quite easy. Okay, type of dry cell. Well, I suppose type of dry cell, you have to talk about the kind of dry cells there are. Maybe what do we use? Alkaline battery lah kan? Yeah, alkaline lah. Alkaline dry cell. Or what is another kind of battery that we usually use? Oh, lithium ion, yeah. Lithium ion dry cell. Actually, this one also can. Okay, or if you want to keep it simple, since we've been talking about internal resistance just now, you can say dry cell with low internal resistance. Yeah. Okay. So if you're going to talk about this, then the reason for this, you can say more. Actually, this is quite a standard answer. More force can be produced. If you don't want to say more force, you can say more current, because more current means more force. Ouch. Okay, more current means more force. Okay, I think you can say that. Okay, number 2, the number of dry cells, more. Okay, more number of dry cells. Okay, which is, you can use the same answer, more force. Okay, more current. Usually dry cells also means more EMF. Okay, if you want a variety in your answers, I think you can do that. Okay, number 3, more number of magnets. Okay, more number of magnets usually is more force lah. Okay, you cannot talk about more current. More force produced or stronger force produced. Stronger force produced. Okay. Yep. Okay, last 2. Sorry, connection of dry cell. Let me add this page. Okay, connection of dry cells in series. We saw this question just now, right? The more, like in the electric car question, the more, if you put the dry cell in series, the homopolar motor, you put the dry cells in series, it means that you have a high EMF. Okay, high EMF means high current. High current means high force. Okay, or stronger force produced lah. Okay, all these same answers you can give. You don't have to give all 3. Give one also is enough. Okay, but there are a lot of variety to these answers lah. Okay, the last one is what now? Characteristics of wire. Okay, this is a very standard answer. The first characteristic, of course, is low resistivity. Okay, low resistivity wire. Or what is a low resistance wire? Copper. Okay, copper wire. Why? High current. Okay, high current, high force. Macam bosan sudah lah ini reason ni kan, balik-balik sudah ni. Okay, or high magnetic field, stronger magnetic field because there's more current lah. Okay, stronger temporary magnetic field. Another possible thing about the wire, you can also say thick wire because we know that thick wire always means low resistance. And low resistance always means okay, high current, high force, high magnetic field. Okay, done. Okay, we're done.